Number 5. All right, ready? Are you recording already? All right, here we go. Number 3. A woman is pulling a snowmobile up a ramp. The ramp makes an angle of 40 degrees to the ground. Draw a good picture, kind of to scale, with all of the forces acting on the snowmobile. So here's my incline. $40. There's my snowmobile. It says the machine weighs 1,010 newtons. So the weight force is down. It is already in newtons. So do not multiply it by 9.81. It's supposed to like save you a step. So this is 1,010, and that's the weight force. If the sliding coefficient of friction is 0.4, what force will she have to exert to pull the machine up the ramp? It doesn't say that it's accelerating up the ramp, so you can assume a constant speed unless it tells you otherwise about a changing speed or a acceleration or something. So she's applying a force up the ramp. What other forces are acting on the snowmobile? The normal force. The normal force is always perpendicular to the two surfaces in contact. So snowmobile on hill, hill back on snowmobile. It's a reaction force. What else is acting on the snowmobile? If they give you this, you know what force has to be there?
Friction.
Friction. And friction is always opposite the motion, but parallel to the two surfaces in contact. So opposite the motion, which is up the hill, parallel down the hill. Here's all the forces acting. Next step in the process. For any forces that are acting in both X and Y, I need to break into their X part and their Y part. So, if my incline is the X, perpendicular to the incline is the Y, what's the only force I need to break into its X part and its Y part? Just the weight force. That's the only one that's not along one of those axes. So the weight force is into the board and down the board. Make sure your X and your Y make a right angle to each other. A super common mistake is putting your X-axis still straight across your paper. If I did that, my right angle would be at my hypotenuse. Don't do that. Make sure your X and your Y are perpendicular to each other. Your X is along the ramp. The Y is perpendicular to the ramp. Now, if I know my incline is 40 degrees, I know my angle inside here will be 40 degrees. We talked about that geometry before. Now, in a problem, if you're ever lost and I don't know what to do, if you are given an angle and a hypotenuse, the least you can do is find the X and the Y, or the two sides. So sine of 40 is the X. Cosine of 40 is the Y. Okay, and you plug those into your calculator, and I will just give you the numbers so that we can move forward. So the X ends up being 649.22, and the Y ends up being 773.705. Okay, now all of your forces are in X only and Y only. At this point, actually, you don't have to use the 1010 anymore. We're done with that number. Now we need to look at net force. If this is going a constant speed up the ramp, the net force, all the forces added up have to be 0. How many forces do you have acting along the Y-axis? You count. Into the board, 1. Or into the hill, 1. Out of the hill, 1. So there's 2 total forces acting in the Y direction. If I have into the board 773, I have out of the hill 773. In the X dimension, we have down the ramp 649. from the x component of gravity. We have friction down the ramp opposing the motion. And we have the applied force up the ramp. That's what we're trying to find. So I already have the value for this one. I do not have the value for these two. I can find the value of the friction though with my new equation. The friction force is equal to the coefficient, 0.4, times the normal, 773. So my friction force is 309.48. So now I have down the ramp 649, down the ramp 309. If I want to pull this up the ramp at a constant speed, I need to oppose both those forces. And so down the ramp 649 plus down the ramp 309 must equal my pull up the ramp. So my pull up the ramp needs to add those two up, and I get a net force, or I shouldn't say net, a net force of 0, but an applied force up the ramp of 959. That's good.